Now, part two of this video is going to deal with the law of cosines. Again, this is going to work for all triangles. This one is initially looks more complicated, but there's a really strong pattern with how these numbers fit in. So given any triangle, okay, I want to start with c squared. C squared is equal to a squared plus b squared minus 2 times AB, notice those are the same sides, times the cosine of C. And notice that that side I started with and that cosine are the same one. Okay, so there's a really strong pattern with how this works. I can rewrite this same formula for every angle. So let's erase this and look at how it would work for, say, angle B. Angle B and side B are where I start. I'm going to write this the other way because I usually write it this way. I'm going to say B squared is equal to, now what are the other remaining sides? That would be these two. A squared plus C squared minus 2 times those same sides. And now this time, it's times the cosine of B. And again, notice that I start and I end with the angle and its side that are in relationship. What does it look like for angle A? A and its side opposite. So we have A squared is going to be equal to, now go ahead and grab these two sides, B squared plus C squared minus 2BC times the cosine. What angle are we working with? We're working with A times the cosine of A. Again, I bookend it with the side and its angle opposite, and the other two sides are in between. Now this B squared plus C squared should look and kind of feel like the Pythagorean theorem. You can think of this minus 2BC cosine of A kind of like a correction to make the Pythagorean theorem work for a non-right triangle. That kind of helps your thinking. The beginning of each of these does look like the Pythagorean theorem. But then we have to correct it because we know that only works for right triangles. Now the trick with this one is absolutely your order of operations. You have to be very, very careful with how you combine terms and simplify these. So let's look at a couple of examples. We're looking for the length of EF. Now EF runs right here. EF is also labeled as little d because it's opposite angle D. So we are going to start with d squared is equal to the other two sides, 7 squared plus 6 squared minus 2 times those sides. And then we close it with the cosine of 60 because that is the angle opposite the side in question. Now it's a matter of cranking out the math. So what do we have? We have d squared is equal to 49 plus 36 minus 84 cosine of 60. You can combine this addition, but don't touch that multiplication in the back. So I've got d squared is equal to, let's do 85 minus 84 cosine of 60. Now, cosine of 60. If you remember from the other day on the table, that's one of our exact values. If you don't remember, cosine 60 is 1/2. So I can put 1/2 in here. So I have d squared is equal to 85 minus 84 times 1/2. D squared equals 85 minus 42 which equals 43. Now remember, that's d squared. You have to take the square root, and so d is equal to 6.6. You could leave this exact if you want, which would be the square root of 43. But again, since we're talking about lengths and those cosine values are often decimals, it's okay to use the decimal answer. The law of cosines also works. Oh, just a quick note. I would not have had enough information the way this was set up to use the law of sines because I need another angle. I would have had to find E, and it would have been too much work. I could not have found it. That's why sometimes you have to use the law of cosines because you don't have enough information for the law of sines. There's no way to set that up for that example. So let's look at finding the measure of x. There's no way to use the law of sines here either because I don't know any of the angles. So if I want to know x, here's x. What side is opposite x? 5.39 is. That tells me how to set up. So here we go. We start with the side opposite our angle. We start with 5.39 squared. That's going to be equal to the other two. 5 squared plus 7.6 squared minus, that 2 is a constant, it's always there, times 5 times 7.6. And then I close with my cosine of x, and that x is opposite. That angle is always opposite the side I started with. Now, we have to somehow simplify this down so that I'm going to have to take the inverse cosine to find the actual angle measure. So how does that work? Again, we're going to be very, very careful. Going to your calculators. Never thought you'd hear me say that. 29.05 is equal to 25 plus 57.76 minus 76 cosine x. Now, you can add these two. You cannot subtract that 76 because remember, order of operations, you have to multiply first. So I have 29.05 is equal to 82.76 minus 76 cosine of x. My variable in this is the idea of cosine of x. So how would you solve that if perchance it said something like 29.05 is equal to 82.76 minus 76y? Okay, think like it's that. What would we do? We would subtract 82.76 from both sides. When I subtract 82.76 from both sides, I end up with negative 53.71 is equal to negative 76 cosine of x. Be very careful with that negative sign because sometimes it's easy to drop it. Now, how would I get cosine of x, my variable, my unknown by itself? I'm going to divide by 76. And when I do that, I get 0.71 equals the cosine of x. Now remember, cosine and sine always have to be less than 1. So if you get something bigger than 1 right here, you did it wrong. Go back and find your mistake. So I need to get the cosine out. I need to find the angle out. So I'm going to take the inverse of 0.71, and that will give me x. And I find out that x is 45 degrees. Now I usually like to carry 1 or 2 decimal places unless it's obviously going to round up. So let's look at some mixed examples. When to use which formula? All depends on what you're given. So the angle E here. Well, if I look at it, this is potentially a law of sines problem. But Mrs. Green, we don't know little side E. But I can get there because if I know these two, law of sines, I can find F, law of sines, and then I can use my angle sum to subtract and get E. So first step, I'm going to use the law of sines to find angle F. So that is the sine of 66 over 6 equal to the sine of F over 4.88. Often in these problems, there isn't a direct method to get to your answer. You'll have to go through another angle or another side. When I cross multiply this, I end up with 4.88 sine of 66 equal to 6 sine of f. Divide both sides by 6, 4.88 sine of 66, all divided by 6, equal to the sine of f. Go to your calculators. I end up with the sine of f being equal to 0.74. Sine inverse of 0.74 is equal to 47.7. Now step 2, it's as simple as saying that angle E is 180 minus 66 minus the angle I just found. And so angle E is 66.3. Now you can use the law of sines to check your work. You can, backtrack your work. You can use the law of cosines to check your work to make sure everything is working out. If again, I'm asked to solve a triangle, they want all missing values. That is a given in that direction, solve all missing values. So obviously in this triangle GIH, I'm missing angles. If you are missing all of your angles, the only first choice you have, the only thing you can do first is law of cosines. Then we're going to use the law of sines. Then we're going to subtract from 180. Multiple steps, and we'll probably run out of room. So here we go. Let's, for no reason other than just because, I'm going to start with I. You can start with G, you can start with H, you can start anywhere you want. I picked I. So first step, using law of cosines. So I say that 6 squared is equal to 5 squared plus 4 squared minus 2 times 5 times 4 times the cosine of I. That's just straight applying that law of cosines. Clean it up. 36 is equal to 25 plus 16 minus 40 cosine of I. 36 is equal to 41 minus 40 cosine of I. Again, obey your order of operations. You can add the 25 and the 16. Do not subtract 40. That's a huge place that kids make a mistake because these two numbers right here are being multiplied and you have to do multiplication first. Now you need to isolate the cosine of I, so I'm going to subtract 41 from both sides. So I get negative 5 is equal to negative 40 cosine of I. Divide both sides by 40. I get 1/8 equals cosine of I. Inverse cosine, and I get I is equal to 82.8 degrees. Now I'm going to take that value, if I know this now is 82.8, now I can find either G or H by the law of sines, which is a quicker, simpler formula. So step 2, let's go ahead and just find H. I'm going to use the law of sines now. You could repeat the law of cosines. If you love the law of cosines, knock yourself out. Law of sines is quicker. When you can use it, probably should. So I have the sine of H over 5 is equal to the sine of 82.8 over 6. Cross multiply. 6 sine of H is equal to 5 sine 82.8. Divide by 6. Sine H is equal to 5 sine of 82.8 divided by 6. Go to your calculator. You find out that the sine of H is equal to 0.83. Inverse sine, and H is 55.8. And last but not least, step 3, that means that angle G is equal to 180 minus 82.8 minus 55.8. Whoops, sorry about that. 0.8 for a grand total of angle G being equal to 41.4. And those